Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. Welcome to this episode of Energy Talks, which we call an innovator's journey. This is because I am joined by a true engineering innovator for a coffee and a chat at Omicron's headquarters in Klaus, Austria, to talk about his career in the field of protection engineering and his insights on the digital transformation of power grids. His name is Dr. Alex Apostolov. Most recently, he was elected as a member of the United States National Academy of Engineering, joining the ranks of innovators like Steve Jobs and Bill Gates. Over the past 50 years of his career, Alex has become a leading figure in protection engineering. He continues to be influential in the digitalization of protection systems and the digital transformation of the power grid. Alex is currently based in Los Angeles, California. He is a principal engineer for Omicron Electronics and also the editor-in-chief of Pacworld magazine. He holds 5 patents. He has authored and presented more than 600 technical papers, and he is also the recipient of many international awards. Alex is also the author of a book that was published in 2022 titled Digitizing the Electric Power Grid. Alex, thank you for taking the time to be my guest in this episode of Energy Talks.
My pleasure.
Alex, congratulations on being elected as a member of the National Academy of Engineering in the United States. You have come a long way to achieve this distinction. Where did your journey begin?
Yeah, I am originally from Bulgaria, and I grew up there, and I went to school there, and I worked for 15 years in Bulgaria until I moved to the U.S.
How did you get from Bulgaria to the U.S.?
Well, this was in 1990, so it was right after the Berlin Wall fell and the social system started breaking up. So what happened is I was involved in the elections in Bulgaria, and I was even nominated to run for the parliament, but I said that's not for me. I was still involved in the elections. So 2 days after the elections, I decided to come to the U.S. to see my best friend who disappeared 10 years earlier. So I arrived in the U.S. The following weekend. There was a runoff election in Bulgaria, and they elected a communist majority. And I said, I'm not going back.
When you were in Bulgaria, were you already working in the power industry?
Yes.
What's your background in the power industry, and what area were you involved with?
Well, the thing is that I never wanted to be an engineer. I wanted to be an artist or a movie director. But when I finished high school and I was looking which university to go to, my parents explained to me that you cannot be an artist or a movie director in a communist country when you come from the wrong background. For example, my great-grandfather, he was the first rector of the university in Bulgaria, and he was also a member of the Bulgarian Academy of Sciences. So when I became a member of the U.S. Academy, to me that was unbelievable because he was always the example to follow, and I was able to actually beat him.
You had mentioned that you wanted to direct movies, be an artist. How did you get involved with protection testing?
Well, so actually, since my parents explained to me that I cannot go in these directions where you have to serve the propaganda if you want to do it in a communist country, the other alternative that was non-political was engineering. So I studied for 5 years electrical engineering, and I specialized in protection. And this is where I started my career in an institute in Bulgaria that was dealing with all the design of protection, automation, control system, and the power grid in general for the Bulgarian utility.
How did you become involved with Omicron?
It's a long story because what happened was after I decided to stay in the US in 1990, I started working for a utility in upstate New York, and then later I worked for a couple of companies before I joined Alstom. Alstom is one of the global companies in our field. So I was doing a lot of papers and attending conferences. And then in 94, I was at a conference in College Station, Texas, where I met Sharon and Rainer. Rainer is the founder of Omicron. So we met there and something clicked between us and we became friends. So every conference where I go, Omicron had a hospitality suite, and after the closing of the exhibition time, we will spend hours with Sharon and Rainer and some other top people from the industry talking about life, philosophy, art. So this is how we became friends. And then what happened is I was pushing Omicron to implement the 61850 technology in testing because I was seeing this as the future. And also I was pushing them to have a software for testing protection schemes. But nobody from Omicron wanted to do it. So then I talked to Rainer about it, and Rainer said, would you be interested in doing it yourself? So I started writing this software with my wife without any support from anybody from Omicron, but I believe that this is something of value to the industry, and Rainer supported me. So that's how I got formally involved with Omicron even before formally joining. And the formal joining was when it was in Florida and Rainer said, I need to talk to you. So I said, sure. And he said, do you remember what you told me 3 years ago? And I said, I don't remember. So he said, you said that the industry doesn't have a magazine. And he decided that he is going to support starting a protection, automation, control magazine. And he said, you will be the editor-in-chief.
What was the name of this magazine?
Well, there was no name at the time. Today it is Pack World. And I couldn't resist that because this brings together my artistic side and my technical side.
Now, that is a publication that is still very prevalent in the industry.
Yeah.
Are you still involved with that magazine?
Yeah, I'm the editor-in-chief.
Going back to your involvement and interest in the IEC 61850 standard, could you tell me what is so important about this standard in the power industry, and how did you see it transforming the landscape back then?
Well, it's a story by itself because when I started my career 50 years ago, everything was electromechanical and hardwired. And one of my first projects that I had, I designed a protection scheme, and then a couple of months later I had a change of mind and I proposed some changes. And the head of the substation department told me, never do that again, because what you're trying to do is change the wiring in the substation, and this is something that is very expensive, time-consuming, and dangerous. So never do this again. And since that moment, I was dreaming of a protection and control world when everything is digital. And this is where my drive for the digital transformation of the industry started. But you were asking about 61850. In 1995, we started in the US a project called UCA2, the Utility Communications Architecture. And I was involved in that because of my drive, and actually I came up with the idea of what became known as the 61850 logical nodes. And I was also one of the 7 people that came up with the Goose idea, the generic object-oriented substation events. So I was involved in 61850 before 61850. We decided that it doesn't make sense to develop 2 different standards, and the members of the UCA task force became members of the 61850 working group. And I have been working on this development for quarter of a century.
Could you tell me how this has changed over the years? Not only the standard itself, but also enthusiasm for it and actually how it is played out in the power industry.
It has been very challenging because the power industry in general, and especially the protection people, are very conservative. So I have had this experience in the past in Bulgaria when I wanted to implement some protection schemes using programmable logic controllers, and the head of the protection department said over my dead body. And it's a similar reaction to 61850 by many utility people because it's the fear of the unknown. It's a completely different way of doing things. And especially from the testing point of view, it is a completely different environment because when we do testing in a live substation, we have to isolate the test equipment and the test object from the rest of the substation, and this is done using what is called test switches. But when everything is communications based, there is no test switch. So we had to introduce in 61850 what we call virtual isolation features, meaning that you put some data attributes that indicate that what you're receiving is not coming from a device in a normal operating mode, but is coming from a device that is being tested. And there are a lot more advanced features, but I think it will be too much to describe in such a short time.
Okay, well, you had mentioned goose messaging. Now, that sounds quite unusual, but it's vital for grid stability. Could you describe what is behind goose messaging and how does it safeguard the grid during disruptions?
Well, what typically happens when we have protection control schemes is when a protection device detects a fault condition, it will send a command to other devices to do certain actions. For example, it will send a command to a breaker to trip. It will send a command to the auto-reclosing to initiate or breaker failure. In the Goose, it's a different philosophy. So what it is, what we call unsolicited reporting. So it detects an event and it sends a message that this event has occurred. And then some other devices in the system that subscribe to this message, they know what to do when such an event occurs. So this is similar to if you are in a hotel and you hear the fire alarm, people know what to do. The people that are guests, they have to leave. The people that are involved with security, they need to figure out what's happening. So it's a similar concept. You send the message, something is happening, and then the different actors will know their responsibilities for this kind of event. And this makes the communications much more efficient, but also the performance is faster than the hardwired. Because, for example, an output contact of a relay typically takes about 3-4 milliseconds, and the goose typically is less than 1 millisecond over the Ethernet network. So it's more flexible and also faster. And now we extended it outside of the substation. So we have what we call the routable goose that allows you to use the internet for a free communication media and be able to implement protection and control schemes where typically they cannot, because the conventional implementation requires a dedicated communications channel.
Interesting. And I'm sure that also carries some cybersecurity issues with it as well.
Yes, absolutely. This is also very critical, but we should not forget that we live our lives in a digital world where cybersecurity is a concern for each one of us at every moment in time. But that's why, for example, when you are in the substation environment, the goose is operating over what is called layer 2, which is not routable communication, so it is considered isolated from the wide area communications. Once you go outside of the substation with the routable goose, then cybersecurity becomes a concern. And that's why we have introduced encryption and authentication of the messages so they can be secured. But this doesn't mean that a very skilled hacker cannot penetrate the security parameter. That's why we have a patent I call functional security, which means that we do additional checking based on our understanding of how protection and control devices work. So, for example, if somebody is able to penetrate and send a message indicating fault condition that will normally lead to a trip, we do checking if there is a voltage drop or current change, step change, indicating that there is a present fault condition. And since this is faster detection than the protection operation, if I receive a message indicating a protection operation, but there is no message I have already received that there is a fault, I'm saying this is suspicious and I will prevent the undesired tripping. So this is how we can combine the conventional cybersecurity tools with our advanced power system knowledge-based tools.
Very good. If we're dealing with a multi-vendor substation, how does the IEC 61850 standardized communication model, especially the Abstract Communication Service Interface, also known as ACSI, make it easier to ensure that devices from different manufacturers can talk to each other without needing custom protocols?
Well, the thing is with the 61850 is a standard protocol that relies on several things. It's the Abstract Communication Services, but it's not just the communication services, it's also the data model that is standardized. So many protocols use standard communication services, but the modeling is not standardized in any of the other protocols the way it is in 61850. However, the challenge for interoperability between different vendors or even within the same vendor is because of the fact that many of the things in the standard are optional. Because you always have to find the balance between interoperability and flexibility. The more flexible a solution is, the less interoperable because it can be implemented in different ways by different manufacturers. So, for example, when somebody puts a product on the market, they have to go through certification testing. So there is testing procedures that every device has to go through to be certified. The challenge is that even if it is certified, it doesn't mean it's going to be interoperable because some vendor may implement a portion of the optional data and data attributes, and they may not be implemented by a different vendor. So even if they support the communication services correctly, they may not understand each other because of the difference in the object model implementation. And this is what has to be very carefully analyzed.
Thank you, Alex. So another point is with the rise of solar and wind power, it's like adding new players to the energy team. How does IEC 61850 ensure these diverse sources play well together? Are there any advanced features or hidden capabilities that could further enhance this integration? Or how do you see IEC 61850 evolving to handle the dynamic configuration of the grid and ensure seamless integration of these resources?
Well, it's a good question, and actually what has been happening from the very beginning, when we started 61850, it was a communications protocol for substation automation. But since people started seeing the benefits and realizing how helpful it is for the advancement of protection, automation, and control technology, they started pushing for support of other domains. So what happened is we started additional working groups that were targeting the object modeling of these different domains. So there was one working group that was looking at hydropower plants, working group 18 and working group 17, which was looking at the integration of distributed energy resources and distribution automation. So what we have is we have a group of domain experts and modeling experts that were also involved in the development of 61850, working together to cover the specific requirements of these additional domains. Now, when you say how does it benefit the integration? Well, because especially with the routable communications, when you have multiple distributed energy resources being located at different physical locations, we can much more easily integrate them based on the communications using wireless technologies such like cellular and other internet-based technologies.
Thank you, Alex. Can you explain the concept of cross differential protection and its significance in digital substations, particularly for double circuit transmission lines?
Well, the thing is that I was talking about IC 61850 and communications-based protection, automation, and control. And this is something that is predominantly based on the technology. However, communications may fail, and we have to find a way to deal with abnormal conditions even when the communications are not there. So, for example, one of the challenges with the protection of systems with high penetration of distributed energy resources is the requirement for high-speed fault clearing. And when you have a transmission line, typically without communications, about quarter of the line is protected with zone 2, which is tripping times that will lead to the loss of many of the DRs. But if you have a double circuit line, which is in many cases in many countries, you can compare locally without communications the currents on the parallel circuits. So if you have an external fault or load condition, it's almost identical, so there is no difference. But if there is a fault on one of the circuits, then there is a significant difference between the current on the two lines at the same substation. And this is a cross-differential current that can be used, and by doing this technology, you can clear without time delay faults up to 97% of the line. Much longer, actually, instantaneous tripping.
Another interesting aspect is that we know or have heard about self-healing grids, but what about self-learning grids? Alex, if you could teach the grid one new skill using artificial intelligence, what would it be, and how would the grid use that skill?
Well, to me, you cannot have a self-healing grid if you have grid that doesn't know what its state is. So the first step in my mind towards a self-healing grid is to make the grid aware of its current state. And this is where actually 61850 can help significantly because we are continuously streaming the analog and the binary status data that can be monitored by AI or machine learning applications that can detect conditions that normally we may not be aware of.
Is this already happening now?
It is happening to a certain extent, but there is a lot more potential. So, for example, since we have tools like the station guard that are capturing the traffic on the substation network, if we monitor this data and if we learn AI-based algorithms that are going to detect any deviation compared to the normal behavior, we may identify potential problems before they become severe enough to cause some trouble to the power grid.
Alex, what totally awesome idea have you imagined to implement in power grids?
Well, I think the direction is clear. It's a digital transformation. And it's what I have as my dream is IC 61850 everywhere. Because the standard has been in service now for a quarter of a century. We have a lot of experience and it has proven that it works. But the biggest challenge, as usual, is in the human brain because it's very difficult for many people to open up their mind and accept something that they're not very familiar with. So when you say my vision is no humans, everything is controlled by the machines, because I don't know if you know that the human brain is too slow for the power system protection functionality. A simple reaction to a simple event, for example, to push a button when a light comes up, takes us about 200 milliseconds. And I was mentioning that the goose message takes 1 millisecond, and the modern protection relays, in some cases may detect a fault condition in 2-3 milliseconds, 100 times faster than the human brain in simple cases. So I think we need to open to the technology, understand better how it works, try it to make sure that it meets our requirements, and then rely on it.
That is a big word, reliance. To be able to trust something where no one is really involved, only machines. And I guess you could look back to the history of computing and how reliable supercomputers have been in making fast calculations of various scenarios. How can we feel better about this coming our way?
It's knowledge. It's, for example, when a child is born and when it starts growing up and when it starts walking, it makes a few steps, it falls, then it gets up, then it makes some more steps and it learns and becomes confident, then it starts running, and then it starts doing a lot of other things, but it's based on experience and gaining confidence in your abilities to deal with different conditions. So, for example, this is the approach that needs to be taken by the utilities. They need to create labs and have these labs as swimming pools. Sometimes when I talk about this, I give an example that nobody learns to swim watching PowerPoint presentations. You go in a shallow pool, you start learning some basic skills, then you go into a deeper pool, and then once you feel comfortable, that you are not going to drown, then you can go into the lake or in the sea or the ocean. But you cannot just watch a PowerPoint and jump into the ocean because you're not going to make it out. So it's the same with this technology. Set up a lab, get the Omicron test equipment, get a bunch of ideas from the manufacturers, start playing with them, and when you feel comfortable with it, you will rely on it because you know that it works.
Alex, have you ever had a crazy, innovative idea that you almost did not consider pursuing because of pushback at the time from your colleagues?
Well, I've had many ideas, and my experience through my professional career has been that almost every time when I put a new idea on the table, the response is you're crazy. So then it takes about 10 years for people to realize that what I have proposed makes sense. And this applies even to Omicron, because when I was with Alstom and I was working on the development of IC 61850, I talked to Rainer and I said, you have to implement the goose-based testing in your test devices. And many people in Omicron were saying, you're crazy, nobody is going to do that. But Rainer was open-minded, he was a brilliant guy, and we talked a lot with him about it, and he said, we'll do it. So this is how Omicron became the first company to implement 61850-based testing features, and this opened a lot of doors for Omicron in places where previously it didn't have access to. So this is one of my crazy ideas that I believe has directly benefited Omicron even before I became formally an Omicron employee.
So you had faith in it, and you also had to exercise a lot of patience before others around you also had faith in the idea.
There are many other things that have taken 10 or more years, and there are still things that I'm pushing within the industry and within Omicron that after more than 10 years are picking up.
What contributes to that?
It's a human nature issue. So, for example, there are two approaches to looking at life. Most of the people normally look at the trees, and you have to see the forest in many cases to get the big picture. So this is something that is, to me, challenging to many people, to be able to go beyond their narrow area of expertise, because when you go into digital transformation, you have to consider a lot more things than maybe you have dealt with in your professional life. And this is the challenge, the human mind.
Good point. Are there any humorous or unexpected stories from your past experiences with protection testing?
It depends on what you consider humorous, because when we talk about humor, it has a lot of history behind it, because it depends on the social environment that you grow up. It depends on the cultural traditions to consider something funny. So I would not say humorous necessarily, but unusual. So, for example, when I was in my first job at New York State Electric and Gas, we had a 6-phase line. That was the only 6-phase line in the world ever. And we were doing commissioning, and we were doing modeling and simulations of something that was never done before. So I went to our management and I said, we need to do stage faults. So we need to apply an actual fault on the transmission line and capture the waveforms and compare the models and see if the protection works. And they said, no way. And I said, why no way? I have done this at 750 kV in Bulgaria. So why not here at 150 kV? They said, because in this country we have lawyers. So they didn't let me do that, but actually Then I said, can we do low voltage tests? So instead of energizing the line with 160 kilovolts, we energized it with 120 volts. And then we were able to do actual testing with a programmable logic controller and make sure that everything works. So you always have ways to find a better solution when you know what the problem is.
So, if you could write a letter to your younger self, what advice would you give to aspiring engineers just starting out in protection testing and IEC 61850 based on your own journey?
Do you see what is on my t-shirt?
You have the words what and why and how.
So this is the three questions that we have to ask whatever we do. What am I doing? Why am I doing it? And how I'm going to do it? Because I have seen through my 50 years career many times people that are doing something without actually, when you ask them, why are you doing this? They don't know. They say, oh, because that's the way we always did it. That's not an answer. So whatever I'm asked to do, I first try to clarify what exactly we're talking about as accurate as possible. Then what is the reason to do it? Because the reason to do it will determine to a great extent what tools we are going to use to solve our problem. So that's what I am going to say. Always ask these three questions and don't be afraid to be yourself. Don't be a follower, be a leader.
I like that advice. Alex, what do you see in the coming future? What is on your plate right now?
Life. The future does not exist. The future is a hypothetical possibility of some things happening. What is going to happen, we don't know. We have to have a certain idea of where we would like to go and make the steps in this direction, but without having expectations. Because my experience is that the reasons that people are not happy is because they do almost everything in their lives expecting something in return. I never expect anything in return. I do what I believe is right, and whatever happens, happens.
Given your experience and all of your contributions, we sure can all rest assured that, especially in the area of protection testing in 61850 communications, we're certainly headed in the right direction and are doing things that are important now. We certainly look forward to seeing how that will shape power grids. So thank you for sharing your incredible story and insights with us in this episode of Energy Talks. Alex, one more thing. You mentioned that you are the editor-in-chief of World magazine. How can our listeners get more information about this industry publication in case they would like to subscribe to it or maybe read more about it?
They can go on the website, which is pacw.org, and there they can subscribe to the magazine, but also they can go into all the issues, and there we have in a flippable PDF format all the previous issues, 17 years.
Very good. And what would you say is the primary content?
Well, it's protection, automation, and control in principle, but we have been focusing mostly on the evolving technology, digital substations, centralized substation, virtualization, 61850, distributed energy resources, everything that is a challenge to the industry, that's what we focus on.
Very good. Very interesting. And thank you again, Alex, for the time.
My pleasure.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.